Good morning, everyone. Welcome to our talk, Taking Refinery Off the Rails. I'm Phil from Manuka Coalition in New Zealand. I live in Christchurch. It seems there's been some confusion. Everyone's like, you live in Auckland, right? Or Wellington? No, Christchurch. I've been involved in the Ruby scene for quite some time now, and I'm pretty interested in contributing to open source. I gave a talk here, I think, 2 years ago, at the last Melbourne conference anyway, about succeeding in open source, and thanks to the power of an anonymous CFP, I got back in. I also really like to travel, and with me today is my colleague Sam. Sam and I worked together on building the Refinery prototype that we'll be talking about this morning. Sam's primarily a front-end specialist and cares deeply about web performance and board games and beer. So the flow of the talk is basically this. First, we'll explore Refinery's current position, how it's currently implemented, along with some of the technical debt that we've found with that and some pain points that we've run into it. Next, we'll look at the HANAMI framework, which you may have heard about a couple times this conference already, along with dry RB. To answer the question, is it a better alternative than what we're currently using? Finally, Sam will talk about architecting a modern CMS that is API first and hooked into Webpack. So, Refinery CMS is the topic of today. It's a content management system. It may seem obvious how it works, it just manages content, but it's built in kind of a neat way because it's distributed as a few core Ruby gems and many extension gems, and these are all written as Rails engines. It hooks into your Rails app and provides content management functionality, of course, for building web applications. So you still have control over some more advanced aspects of your site because you can still write Ruby code and any JavaScript and CSS that you want. This lets you or your customers edit content without redeploying the website, which is pretty key, I guess, for a content management system. So we call it a Rails CMS, and I've just mentioned it's the most popular Rails CMS. So what do we mean by Rails CMS, though? Well, it only works with Rails. Yay. So given this, why did we choose to base a CMS only on Rails? Well, first of all, I mean, Rails was around, and Rails does a lot. We get a lot for free, and it lets us be extremely productive to begin with. It's built for the 15-minute blog. It's built to get you up and running. It's built to support your app so that you can write productive features really quickly and ship new features fast. And this helped us to get really popular quickly, which was quite important because we got a lot of developers involved, and they helped us to extend the system. And I've even had conversations with people here that say that they use it, which is quite humbling. Also, Rails has a huge market share, for better or for worse. It seems like every Ruby gem is written for Rails, well, almost every Ruby gem, as we've discovered, and hooks into Active Record in some way to add magical special features that you never knew existed in your app to begin with because they're magic. And it does that really easily, and so it's quite friendly for the developer. Like you just, you put the gem in your gem file, you run some command, and it's there. Rails is also actively maintained, which is a really great thing to have in a framework. But I found this to be quite a double-edged sword. As a gem maintainer, this can make life extremely hard. There's new versions of Rails coming out all the time, and you'd think that only the major versions would be a problem. No. This can make life extremely hard because there's this expectation that if you've got a gem that uses Rails, that you will support the latest version immediately, like immediately, as in if it's not within 6 hours of the release, you've got issues on your issue tracker saying, hey, where's the Rails 5 support, or where's the Rails 6 support? Which is great that people are so interested, but this is a huge burden that it places on gem maintainers because everyone expects that you're up to date. So my angle on this whole talk is from a gem maintenance perspective. It's not about writing web apps with Rails. It's about maintaining software that lots of people use in the form of a library that people can put into their own projects and make their own web applications. So from this perspective, it's been really tempting to use all of Rails public APIs, and so that's, we've done that. We've used a lot of their public APIs, And would you believe it, Rails has a lot of private APIs, and you can achieve these very easily with some nice monkey patching. So guess what? So this helps us to avoid doing any real work ourselves, and gets us nicely coupled to Rails. So from this, from a gem maintenance perspective, makes life quite tough for all the reasons I just said before. So this is what we're at the moment. Refinery ended up being very coupled, and while this means we get to use a lot of the features, it adds a lot of burden for support and maintenance. So this means we built up a huge pile of technical debt. Each version of Rails that came out, we quickly made it support that and made the hundreds of failing tests into passing tests in the easiest way we could with the time that we're allowed, because it's open source, nobody's really paid to do it. So we just moved on as quickly as we can, as elegantly as we thought we were doing it, and moved on to the next version of Rails. So Sam and I started to talk about ways to reduce all this technical debt when I showed off the project to him and explained all the problems I was having. And we talked about ways to modernize the CMS, which he's going to go into more depth later on. But instead of slowly chipping at it from within the current solution, we decided to do what everyone loves to do, get a bit creative, try something else. So enter Hanami. Hanami's already been brought up yesterday in the single track talks. It used to be called Lotus. A few people have said, hey, have you used Hanami? And they're like, no. And then I say Lotus, they're like, oh yeah, Lotus. I think there was some sort of a trademark problem with that name though. If anyone is familiar with any sort of Lotus software for maybe making spreadsheets or maybe emails. So we thought we'd give it a shot, building some of the core concepts that we had in Refinery with Hanami instead. So I'll run through basically what we found through that. Hanami feels really Ruby-ish, which is probably the biggest surprise I had going in. Like, it feels really natural. It feels like it just builds on top of Ruby. It's extremely composable, which means that we don't need to focus so hard on learning the Hanami way, like we did with the Rails way. Like Refinery's website currently says that it follows the Rails way. But we didn't have to worry about that this time. It just lets you lean on your understanding of object orientation and of Ruby. And sometimes, more especially these days, on functional programming understanding, which is pretty neat. Hanami encourages a proper design for database access and persistence. This I found to be relatively restrictive. You can't just go into your views and write a database query like you can with Rails, but because nobody does that though, so that's fine, right? But I found that that is actually a really good thing. It makes you stop and think about it, and instead of just writing a where query in your view template, you actually have to go into the repository, write a proper method to retrieve that data, and give it a proper name, and test it properly, and make sure it's like actually in your public API for everything to use. It's not just this hidden, undocumented, untested thing. This is similar to how a library, I think it's similar to how Ecto works, which is an Elixir library. Elixir, tick. Good job. Hanami also encourages a separation of concerns in your app. The intent is that all of the Hanami libraries can be used completely independently of each other, which may be very unfamiliar if you're used to other solutions where you're expected to use the whole stack all the time. While they're used independently of each other, they're actually also extremely complementary when used together. All of the different libraries that Hanami's made up of, they just talk to each other quite naturally, and it's quite a pleasure to use. Now, the real bonus is that Hanami nowadays is built using dry RB libraries. This wasn't always the case, but I think it's a good testimony to Hanami's vision and Hanami's creators that they were able to collaborate with dry RB and not be so not invented here about it, and replace some of the core implementation of the library with some, well, now existing tools, which I don't think were existing at the time. The beauty of this is that we can learn dry RB technologies and use them directly within Hanami through their abstractions that they've added. I think it's extremely helpful to rely on smaller, reusable components instead of like a large framework which is trying to do everything. And all these things provide solid first-class APIs. So what do we get from this, though? So one of the coolest things about what we get is this, it uses this library now called Drive Validation to do all of the validation work inside Hanami. This is an extremely powerful validation library based around the idea of predicate logic. Tim Riley covered many aspects of this already, but I'll briefly explore how we can use it with Hanami. So let's say we have to post some JSON. This is a data structure which we might send to our server to construct a page, because it is, after all, a content management system. And what is the God object of that but a page? So as you can see, the page has contents. Each content has a content type, and it has a value schema, which is just a subhash full of a bunch of key and value pairs. It has a title and it has a slug so that we can find it. So if you remember what that looks like, we'll go to the next one, and you'll see that there's this params block, and it looks just like the JSON from before, but specified with Ruby code. I'm not usually a huge fan of DSLs. I think that they can make it seem a little bit too magic-y and seem like you're, some complexity swept under the rug a little bit to use it. But this one actually helps us to mirror the data structure really nicely, and I think it makes it really readable. Like, I'm pretty sure most of you can see what's going on, hopefully, with this. So server-side, what this lets us do is validate the JSON immediately, and you'll notice it's outside of any call method, which I've omitted because this is slide code, and you can only fit so much code on a slide. So there just wasn't room for a call method, or I could have just made it really tiny. No thanks. But we didn't need it to demonstrate this because you can see that everything is validated just by specifying this. And if you've used strong parameters before, you may be noticing how there's no subhashes and there's no subarrays and arrays for hashes, and I don't even know. And it centers around the idea of predicates. So you can see at the end of lines 8 and 9 and 12, 14, 15, there's these querying methods with the question marks at the end, which in Ruby means it's going to return a true or a false, or a truthy or a false. Yeah, I get confused. So you can see it's asking whether it's content type ID is an int, whether the value schema is a hash. That could actually be a more complicated predicate that said, is it the right value schema? Like, does it match what we're expecting? And then the others are just string, int. And what is really amazing is that we get support for optional parameters, which I don't know if I've seen in many libraries before, where we can say, if this thing is around, which it doesn't have to be, that's totally cool if it's not there, but if it's there, it has to be a string, or it has to be an int, or it has to be a hash. And so if we don't supply it, like in the JSON we posted, we didn't even supply a template ID because we're not building it based on one. And the server's just like, don't care. But if we had passed it, it would have been validated really nicely. So the next thing Hanami now gives us is access to Ruby Object Mapper, ROM-RB, which Piotr talked about a lot yesterday, which just has version 3.0 and has gotten even better. So Hanami now uses this to back up all of the entities, which at first just meant I had to rewrite all of my code. But then I delved in and struggled with docs and gave lots of private messages to lots of the maintainers, and now I have discovered how great this gem actually is and how useful it is, and kind of got past the learning cliff of it and discovered it's really nice. This adds a layer on top of the portable SQL gem by Jeremy Evans, which does all the raw querying for SQL queries. I think there's other backends for graph databases and stuff. I haven't really looked into it that much because I haven't had to do that yet. It maps SQL to lightweight Ruby structs, which was shown off yesterday if you were there. Gives us access to dozens and dozens of SQL extensions that they're useful to query many things, or like build nested sets or ancestry trees. Like there's tons of cool stuff in there, and now we can use most of that stuff, including JSON-B support, which we needed for our system. Because what's better than a relational database with some NoSQL? I can't tell you what's better than that. This means we can do cool stuff like write queries like this to search inside Postgres JSON-B fields. So by JSON-B there on line 7 is just a simple query method that I wrote that just takes a key and a value pair and looks inside the value schema field, which is a JSON-B field inside Postgres. And it finds all of those using SQL's PG JSON-B extension that contain the key that equals this value. and this is really fast. On my test sample of dozens of records, this was really fast. It then, on line 9, it uses the as entity, which is I think it's a Hanami thing or a dry thing, I don't know, but it just works. And this, I'm pretty sure it's Hanami. And it maps it back to being the entity that it's expecting, because Hanami has certain conventions, like this repository will talk about these sorts of entities. And so rather than giving us dry structs, this maps them as Hanami entities, and so they act like them and they quack like them, and all those cool things that we get from OO. Find by JSON-B just reuses by JSON-B and then adds .1, and this just limits it to one result, so it just finds the only one that matches this or the first one. Which is really neat, and it's an example of that you can just reuse existing functionality so quickly and so easily. So from a gem maintenance perspective, and this is the main thing that I come to this with, now that we've seen that Hanami and dry-RB make a pretty compelling combo, hopefully you agree, I mean I do, what does this mean when maintaining library code for a gem or a whole set of gems, which is my problem? Well, first of all, code lives in the lib directory. Yes! This means that we don't have to couple to Hanami's ideas like I thought I did with Rails anyway. Hanami's ideas around code structure don't apply. I can actually just make a lib directory full of code, and that makes it really easily testable in isolation. There's no auto-loading. I mean, you can turn it on, but it means putting require where it's needed. Sorry. But this means, I think, that you end up with thoughtful dependencies, because when you have to specify all the things you require, it makes you a little bit embarrassed when it's like 16 things. And you go, maybe this class, maybe it's not doing its single responsibility. So what I also think is that if we were to take this proof of concept and package it as a gem, like if we were to probably redo this at this point, we would rely way more heavily on dry-RB technologies rather than coming at this with the aspect of, oh, this is just another Rails app. Let's rebuild it like we build a Rails app. This gives us a lot of horsepower, and it already does a lot of the stuff that we need it to. And most of the code for a web app is actually just code that you'd use in a Ruby app, and it doesn't need to live in the web endpoint stuff. It can just be generic code that is then used by your web boundary. We can also ship it with an app per endpoint. Rather than shipping one large library that has every single endpoint that we ever might want, we can just ship little modular gems that hook into each other, and like maybe you'll have a pages endpoint, and you'll have a content types endpoint, you'll have an images endpoint. These are all just tiny little apps which don't really have much of their own code, but just call on other libraries that do the actual business logic. This is something I found neat anyway. And these can just be tiny little single-purpose rack apps that just hook into Hanami, preferably, or maybe something like Dry Web Rotor. This means that the user can just turn on or off features pretty easily. Just take it out of your gem file, I guess, hopefully. And this is something that, unexpected, I think, that Hanami and Dry encourages, like you can actually just do these sorts of things. Whew. Well, that's all from me. So now I'm delighted to hand over to Sam for the remainder of the presentation. Thank you, Sam.
Cool. All right. Hi. This is my first conference talk, so this is pretty exciting for me. Yeah, give me a hand. Thank you. So awkwardly, I'm going to be talking about front-end development, which includes JavaScript. And there are no jokes in my slides because JavaScript is really serious business, okay? Don't laugh. Yeah, so I'm going to talk about the front-end considerations we made when making our prototype for Refinery. But I'm also going to talk about some of the design decisions that we made around making a more modern CMS. So the first thing we wanted to do when thinking about how Refinery could be better and more useful was to design an API-first CMS. So in the kind of architecture and planning phase of this prototype, we decided it should be purely a JSON serving API. This was a massive step forward for Refinery because in the past, Refinery has been a whole bunch of custom JavaScript, some Rails forms, and those things kind of intermingling with each other in a bad way. And what we ended up with was quite a bit of coupling between these custom JavaScript files and the Rails forms-driven backend. You know, JavaScript was modifying the rendered forms and stuff, and it was a mess. Every time we came to try and add a new feature or rework the front end, which if you've seen Refinery's current dashboard, it really does need a rework. We found that basically it was really hard to add features. The other thing we thought was a headless CMS is a pretty exciting feature these days. If you've seen services like Contentful and things like that, the idea of being able to host all your content types and that kind of thing in one place and then serve it up to multiple different consumers, that's quite an engaging feature for a CMS. So by designing Refinery as a API-first application, we could just kind of support this kind of thing and have things like multi-site support really easily. Whoops, sorry. I was trying to read my presenter notes. All right. So, building a JSON API with Hanami. I kind of get this feeling, or at least I got the feeling when I first came to Hanami, that I was going to have to relearn, you know, a new DSL, a whole new way of doing things, and it was going to be really hard work. And you know, because it's so new, nothing's really been done for you. But it was a really pleasant surprise coming to Hanami and finding that wasn't the case. It's a lot more mature than I first thought it would be. And so building a JSON API with it was really easy. We just switched on some configuration. That basically said, you know, all our controllers will be serving JSON instead of templates, and kind of just pulled out some of the loading stuff out of the configuration for templates because we didn't need it. And hey presto, JSON API. And the other thing is the dry validation is amazing for building a JSON API. It was so simple. As Phil mentioned, you know, you can design the structure of what you're going to validate and pass. And for coming from the front-end perspective, that's excellent. Like, I think even if you weren't a Ruby developer, you could pretty quickly learn how to shape what you were expecting to send from your front-end and back-end with dry validation. It was very nice. So the next thing we wanted to do was, as I mentioned, we weren't going to use a Rails form backend, so we decided, you know, to start thinking about what our front end was going to look like. We chose React, mainly just based on hype. It's pretty much the way you decide anything JavaScript related these days. Just go on Twitter, look for most mentions, cool. React will do. No, that's not entirely true. It is a little bit true. I like React. I like React a lot. So we decided on React because reusable components and stuff. It's not, you know, you can use any kind of front-end library, but we chose React because we wanted to build up dynamic forms, basically. And React's actually just quite well suited to this task. Anything that would generate components, to be honest, would be quite well suited to this task. We also decided to go into a bit of new territory because as a prototype, we've got time to look at some really greenfield stuff. So we looked at Preact instead of React, which is like basically the same API that React has, but it's only 3 kilobytes. It's really small. We can think about things like performance and you know, making sure that our mobile users with slow connections and stuff can have a nice experience. Right. So I'm going to give you a quick code example. If you don't know React at all, sorry, this will look like gobbledygook, but basically this is just me showing you how kind of it's so easy to do something like a dynamic form with React. So we build up a bunch of field types, and in our content type system, the way it works is, in many CMSs, if you've ever had to build a CMS or work with one, the idea is that users build up their own structure of the content they want to store, like a blog post or an article or something like that. So we build up a bunch of these field types, which, for example, in the case of storing a string, is just a text input. And then we build up a content type form. So this is going to take information from our API, a thing we call the field schema, which is just the structure of the content coming from the API, and then pull together all those field types and generate a form that we can use. And that's just us rendering the form over there. That field schema up the top is basically roughly what the data would look like coming from the server, and then we pass that into our content type form and render it. Okay, so using JavaScript in Hanami is the next thing. So I'm going to talk a little bit about the tooling and what we did there. So first we had a look at HANAMI'S asset pipeline, because I think it's a good idea to see what the framework has built in and have a look at that. Asset pipelines are quite off-putting to me, but I had a look anyway. So HANAMI has an asset pipeline, very similar to Rails one. It kind of looks like from the docs that it supports less formats out of the box. So it supports things like ES6 and JSX and CoffeeScript and a few other things. There's a few shortcomings of HANAMI'S asset pipeline that were quite frustrating. The main thing is that it does support ES6, but if you kind of look down the dependency chain far enough, it relies on a thing called Ruby Babel transpiler. And Ruby Babel transpiler is really cool, but it's locked at the moment to Babel 5. Now, if you know anything about JavaScript, that's quite old now. JavaScript moves at like, a blinding pace, and it's hard to keep up with. But as a result, the further behind you get with Babel, the further behind you are on some really key features that keep coming out as the language, as ES6 comes out, as ES7 comes out, et cetera. Bridging JavaScript tools with Ruby generally feels really bad, in my opinion. Or my experience so far has been negative with not just the asset pipeline, but also gems that try to bridge your JavaScript toolset into Rails or whatever framework you're using. I would recommend avoiding using these tools if you can. The issues I've run into with these bridging gems, and the bridging gems I'm talking about is things like Webpack Rails and stuff like that. The main things I've run into is lack of active development on the gem, and I think the kind of thing that we don't talk about sometimes is that we do put like more burden on open source developers by trying to keep a gem up to date with the JavaScript dependencies, as well as all that effort that goes into building the JavaScript dependencies in the first place. So we always get behind. For example, Webpack Rails, last I checked, is not supporting Webpack 2 at the moment, and I don't expect them to. There's only a couple of developers working on it. It's a small project. But we kind of expect to be able to pick up these libraries like Phil said, and that they should just support the latest thing. So when you need a new feature in any one of these gems, you're usually forced to fork the gem, or maybe there's just roadblocks from you even upgrading it all. So this comes to the point of my talk where I talk about how we just integrated Webpack without using any bridging tools or anything like that. The first step was switching off HANAMI'S asset pipeline and just doing away with that essentially, because we don't need it. Webpack's going to do a better job of all the things that an asset pipeline will do anyway. It was simpler to rely on Webpack for fingerprinting our assets, for minifying them, all that stuff. But of course, there's always that tiny bit of tension where we have some files that our JavaScript tool generates, and our framework needs to find them. So Webpack generates, it has a manifest plugin. So when you hash your files for long-term caching and all that kind of thing, you're still going to have to, they're going to have some really weird, crazy names, and your framework's not going to know where they are. So we decided to build a little tiny bit of Ruby code for this instead of relying on a gem. And I'll talk in a minute about why I think that's a good idea. So running Webpack's dev server in development mode is really easy. You just have something like foreman and a proc file like you'd have on Heroku, and you're running your Webpack dev server in development mode, and then in production you'll have built, minified, hashed, whatever assets ready to go. So another quick code example. Sorry about the purple on black, that's probably quite hard to see. But first of all, we've got a little helper that we include in all our views in HANAMI, and this is done in configuration. And then we take the manifest file that Webpack generated, we load it into memory as just like a piece of config, and then we have this asset helper, and this generates a script tag either pointing to Webpack dev server in dev, or looking to the manifest in production to generate a script tag. Running your own software can sometimes be good. So I think the positives of this is that was a really small piece of code, and I've almost cut nothing out of that. I think the total, including comments and everything, was like a 40-line file to load our Webpack bundles. And you'll notice from the helper that we're not really bridging any of Webpack's functionality. We're not relying on the asset pipeline. We're not expecting Ruby to do any of the minification or processing of our assets at all. All it is basically a script tag helper. The upside of this is that we can maintain a 40-line file. We maintain, tens of thousands of lines of code every day in our code bases. We can handle this 40-line file. We're not going to get behind on Webpack's features. We're going to be able to upgrade constantly. This seems like a good thing. Which brings me to my next point, which is I think it's worth delving into the power of your asset generating tools. So I've only talked about Webpack. Of course, there are lots of others. There's Grunt, there's Gulp, there's Brunch, there's all sorts of things. We just went in on Webpack because of the hype. But basically, your tool, especially in the JavaScript space, is designed to handle these things, and the features that you've seen from your asset pipeline only scratch the surface of what Webpack can do. So I would always favor looking deeper into the configuration of Webpack for things like breaking out bundles and things like that. Webpack has some really special features now, like tree shaking, where it can literally determine, which code you're actually using before it compiles it into your final file that gets served up to users, making your files smaller. It's a powerful tool. And as I mentioned before, it's not your only option. There's Brunch and there's heaps of others. We did a proof of concept with Brunch, and it worked really well. It was exactly the same kind of setup, foreman and running Brunch's, file watcher while you're running your project, and it's a piece of cake. So I kind of raced through that a bit, sorry. So in conclusion, we wrote a proof of concept, and from the perspective of Phil as the gem maintainer, if we did it all again, we'd use less of Hanami and more of dry-RB, so we'd be left with just library code and an obvious boundary between our application and our domain, and not fall into that attractive trap of coupling to yet another framework. But from the perspective of web developers, we're really excited about Hanami. It's simple and fun, and it's got a lot of power in it. And for building it's great for building web applications. Its foundations are built in dry-RB gems, which we have really loved using and had a lot of fun with. If you've ever worked with Rails, if you've only ever worked with Rails, then I think it's worth giving some of these tools a try. Learning new things is just a good thing in general, but it also brings back that excitement and that passion you had when you first started developing, which sometimes gets lost by the wayside when you're knee-deep in some active record stuff. That's how I feel anyway. Oh no, I'm sorry, my presenter notes have gone off the screen. Yeah, so we're excited about the future of Ruby outside of just one framework. And we're also excited about a future where Ruby and JavaScript both play to their strengths. JavaScript obviously deserves to be, I keep hearing first-class citizen all the time. I don't even really know what that means, but I think it means let JavaScript do its thing best, let Ruby do its thing best, let them stand out of the way of each other, and we'll have better, more engaging web apps at the end of the day. And that's something that we're excited about. So thank you all very much.
Thanks very much, Sam and Phil. So we're actually running a little bit early, which is fine because I spoke New Zealander instead of Australian.
Yeah. New Zealanders talk really fast.
So if it's okay with you two, we could probably ask you a couple of questions.
That's fine.
Is that fine? So has anyone got any questions? Go run, quick, someone.
Well, we're not using the app today?
Yeah, we'd totally do that too.
Yeah.
So, Phil, you mentioned being able to have one app for each endpoint. Mm-hmm. Do you imagine you'd be able to then put those apps on separate servers or something for load balancing?
So with one app per endpoint, can we put them on separate servers and use load balancing? Absolutely. So one thing I've seen people do is use an environment variable to boot particular apps on particular servers. So you can actually just build your whole web app as a giant monolith if you want. Which it seems like most companies want to do anyway, because frankly, it's easier. And so they've got different switches in their boot scripts, which will load particular endpoints only if particular environment variables are found. So yeah, you could totally do that. And even in the absence of a monolith, you could do that anyway, because all of your underlying library code should just be gems that you put in your gem file. And so you reuse the same code across different services with different endpoints. So yeah.
Yeah, I'm just wondering, given what you guys know about dry RB and Hanami, and you're saying maybe if you had your time again, you wouldn't couple to another framework, would you guys be looking at dry web rotor, or does that kind of come under the banner of another framework?
Yeah, I mean, it is sort of like another framework. I think that the point we're trying to get at is, so would we couple again to dry web rotor, or does that feel like another framework? The point I think that we're trying to get at with that was that we don't have to write our entire app as if it is the web app. Like, everything doesn't have to be in app controllers, app views, app models. It can be library code that could work on command line. Like, you could write a nice little CLI interface for your app and query it that way if you wanted to. And then you just write a little extension gem for that part of it, just the same way as you can write an extension gem for the web boundary.
We kind of took that typical approach that you do when you pile on a bunch of new technologies, where you're just like, oh, how are we going to serve it up on the web? Oh, we'll start with Hanami, but we probably should have started from the other end, where we're looking at our domain and building that up first, and then worrying about where we serve it and how.
Absolutely.
Hello. So for someone who's quite new to dry RB, I've only heard of it as of yesterday. With these gems and stuff that you're talking about, could you actually put them into an existing Rails application and use these features now, or would you have to like build something from scratch in order to use these sorts of things?
So can we use dry RB tech with an existing Rails app or an existing other app? Yeah, absolutely. You don't have to rewrite everything. You can actually just slot in a little piece and rewrite that part, or make a new feature in just using dry RB stuff, and it will just happily coexist with Rails because it uses completely, well, it uses its own stuff, like it's all quite isolated within itself. So you could replace discrete parts of your app with these technologies and start that way. And I think that's actually quite a neat way of sneaking these things into giant monoliths without corporate approval.
All right, well, that's pretty much leave it there. So thank you very much, Phil and Sam.
Thank you.